They found that the number of seconds was only about 7 seconds on average. And so they then argued on the basis of that very flimsy result that human attention span was only 7 seconds long. And so I believe that maybe they also argued that this was similar to what you might expect from a goldfish. And this idea of human attention span degrading to the level of a goldfish is something that you'll also hear in popular media in recent years. Most people who have not studied this topic, they feel as though they are actually getting a much richer flood of information when they look out at the world. But it turns out that that intuition is just incorrect. Working memories are the only part of your life that you actually will ever experience. This is kind of the definition of what it is like for you to go through life. And so understanding how we control our conscious awareness is just, it's impossible not to be fascinated by that question. We feel as though we have a much broader scope of attention than we really do.
What exactly is working memory from a neuroscience perspective? Have you ever wondered how your brain decides what to focus on in a world filled with constant information? Why is it that sometimes you remember a phone number for a few seconds perfectly, but lose it just a few moments later? And how does attention shape what we actually perceive, remember, and learn? Even though we experience attention and memory constantly in our daily lives, neuroscientists are still uncovering how the brain selects information, filters distractions, and temporarily stores the things that we need in the moment. These questions sit at the center of cognitive neuroscience and today's topic, visual attention and working memory. For focusing in a crowded classroom to remembering directions, solving problems, or even just scrolling through social media, attention and working memory influence nearly every single thing that we do. Understanding these systems gives us insight into how the brain processes the world in real time and how our minds succeed or fail at staying focused. Hello, I'm Avanish and this is The Early Perspective, a podcast where we explore how the brain works and what that means for how we learn, think, and live. For today's episode, we're going to be diving into the neuroscience of visual attention and working memory, two cognitive systems that are essential for learning, decision-making, and perception. When we look around, our brains are flooded with enormous amounts of sensory information every single second. But somehow we're able to focus on what matters, ignore the distractions, and even temporarily hold information online long enough to use it. How the brain accomplishes this is one of the most fascinating questions in modern neuroscience. I'm incredibly excited to welcome today's guest, Dr. Edward O. Dr. O is currently a professor at the University of Chicago. He received his doctoral degree from the University of Michigan, where he trained with Drs. John Jonides and Edward Smith. He then spent the next 2 years at UCSD working with Dr. Hal Pashler and Dr. Steve Hilliard. In 1999, he took his first professor position at the University of Oregon, where he spent 16 years and developed a close collaboration with Dr. Ed Vogel. In 2015, both he and Dr. Vogel moved to the University of Chicago, where he continues his work today. Dr. O's research focuses on working memory and attention, particularly the close relationship between these two processes. More recently, his work has explored the sharp capacity limits of working memory and how these limits may relate to the brain's ability to bind information to a person's current context and experience. I'm really excited for this conversation because attention and memory are such fundamental parts of everyday life. Dr. O, thank you so much for joining me today.
Thank you for having me.
Of course. So, before we begin, I just want to go back to the beginning. Could you tell us about your path into psychology and cognitive neuroscience?
Yes, well, so, I grew up in Mississippi, and in the Mississippi school systems, I had not a huge number of amazing teachers, but the best teachers that I had when I was in high school and in secondary school were my science and math teachers. So this sort of got me into that hard area of science and natural science interests. But one thing that I was kind of starved for in school in Mississippi was some in-depth understanding of humanities and social sciences. These were topics that just weren't well covered in our schools. So when I
Hmm.
got to college at Northwestern University, I was really interested in delving into those topics, taking philosophy classes and other types of socially relevant classes. And I found that psychology classes were a kind of nice way to get more of an understanding of human topics, but while still keeping the math and science training that I'd acquired in high school on the table. So I thought it was a nice kind of marriage of what I already knew and the things I was really curious to learn more about. And that's what kind of got me to take my first psychology classes. And after I took the first one, I just found that I was really fascinated with the topic, and I continued taking them all the way through school. And eventually, I didn't declare my major until my junior year, but when I finally did, it was clear that it would be psychology and neuroscience.
What drew you particularly to combining neuroscience with behavioral research?
Well, it turns out that if you want to understand the neuroscience of the mind, then pretty much you have to be a behavioral psychologist as well, because none of the brain activity really makes any sense unless we can actually connect that brain activity to the mental abilities and behavior of people. So when I want to understand memory, the first thing I need to do is understand how can people tell me what they remember? How can they perform different tasks based on their memory and what they're paying attention to. And so understanding behavior and how to measure behavior is really a core part of being able to understand how the brain allows us to perform those activities.
That's really fascinating. But what exactly drew you into studying memory and attention particularly?
Hmm. I guess it just seems to me like these are kind of core elements of what it means to be a human.
Hmm.
Uh, one way I like to talk about it when I start my class on working memory and attention is that working memory is the conscious parts of your mind. It's what you're currently thinking about. And so if you think about that more carefully, working memories are the only part of your life that you actually will ever experience. This is kind of the definition of what it is like for you to go through life. And so understanding how we control our conscious awareness is just, it's impossible not to be fascinated by that question.
Of course, yeah. I think this is a great segue in straight into our discussion. So I know you talked about the implications of understanding working memory, but what exactly is working memory from a neuroscience perspective?
Yeah, so one way to try to define what working memory is to kind of zoom out a little bit and talk a little bit more about all of memory. So, one way we could talk about memory is for you to think about this idea of every experience that you've ever recorded throughout your life. The whole space of all your memories that we know are stored in your brain. And we can talk about that as long term memory. These are basically all the different experiences and memories that you've laid down throughout your lifetime. Now, within long term memory, we can talk about a very small subset of long term memory that you can hold actually in your conscious mind. And this is what I'd like to refer to as working memory. So I could ask you right now, what was the name of your first grade teacher? And perhaps you could just pluck that memory out of the many millions of memories that you have in your mind. And you can be now consciously thinking about that particular memory. Likewise, you can look around yourself in a room or in any environment that you're in, and you can take in new information, and you can hold that information in mind as well. So your conscious awareness is kind of fed by two different things. There's the outside world where you take in information, and then there's all of your past experiences that allow you to kind of retrieve information from your past. And all of that kind of culminates in working memory. This is where you're actually thinking about that information and using it to guide your behaviors in different situations.
In what other ways is working memory useful for everyday cognition?
Well, it's basically, I would say, it's not just useful, but really it
Mm-hmm.
is where everyday cognition takes place. So
Right.
most of our conscious experiences could not take place if it weren't for our ability to have information in working memory. This is kind of our definition of working memory, is this conscious workspace that we're able to have some voluntary control over. So, you can choose which thoughts you are allowing to be in your conscious mind,
Right.
and which parts of the environment around you you're paying attention to and allowing to come in to affect what you're aware of as well. So if you think about it from that perspective, then almost any cognitive task that you're performing will require some level of control of this kind for you to kind of choose which parts of this busy world around you you're going to actually allow to occupy your limited capacity.
hmm So, in other words, working memory is similar to sort of a mental workspace, right?
Yes, that's a great way to talk about it.
Okay, and then alongside memory, your work also focuses heavily on visual attention. So, from a neuroscience perspective, what is attention? Of course, it's a word used every day, but does that
Yes.
mean something different in science?
Well, attention is an extremely important and popular topic of study in both psychology and neuroscience, but it is also a challenging topic of study. And I think your question gets at one of the reasons why it's challenging, in that everybody kind of feels like they have an intuitive understanding of what the word attention refers to. And yet, when we try to really define exactly what the mechanics of attention are, we quickly start to realize that there are actually many disagreements amongst people in how to perfectly define what attention is. And I think that if we look through the literature that studies attention, both in psychology and neuroscience, we'll see that actually different papers that are referring to this topic of attention may be referring to different phenomena when they talk about attention. So whenever you start to write a paper about attention or to engage in a research project that is directed at understanding attention, the first step is to carefully define what you mean by attention in that particular context. And I think that's an important step for the reader to understand what you're actually referring to as you try to draw conclusions about what you found, but also even for ourselves to try to stay focused on a more consistent definition of what we mean by attention. So one way to try to define attention generally is just to refer to our ability to focus on only a subset of all of the information that is coming in through our senses. So looking around the room, you might see dozens of objects or different things that could be of interest in that room. And one thing that you would realize pretty quickly is that if you tried to pay attention to all of it at one time, you would not succeed. You're not really able to understand dozens of things simultaneously. So that requires you to make a choice, to actually select a subset of the environment to try to take in at one time. And that selection process is one way to talk about what attention is. It's our ability to select a subset of what would be an otherwise overwhelming amount of information to allow to be perceived and to be held in our conscious awareness.
Is the reason why we can only focus on a small subset of the overall information because the brain would be overwhelmed by this much information?
Yeah, I think that's a good way to describe it. That is, we can see quickly that if we ask somebody, for example, to take in 10 words at the same time, that they will not be able to do it, that they will fail
hmm
to be able to actually report what many of those words were. Likewise, with any other kinds of simple stimuli, even with the simplest stimuli that we can think of, like just a simple colored square, for example, people can't really take in more than two or three of these simple objects at a time. And this seems kind of counterintuitive. I think most people who have not studied this topic, they feel as though they are actually getting a much richer flood of information when they look out at the world. Like our phenomenological experience is that we see this very rich tapestry in front of us of all these different inputs that are coming in from a beautiful nature scene or from an urban scene. It feels as though we're getting lots of information at the same time. But it turns out that intuition is just incorrect. And when we use careful objective measures to try to determine exactly how much information a person can take in at one time, it's just far more limited than our intuitions would suggest. So there are a lot of really fun demos that you can find online and in textbooks that help to demonstrate this, that when we really measure objectively the awareness and the scope of awareness of an observer, it's just far more limited than we would have expected before we started studying it carefully.
Right. Yeah. So you're saying that studies have revealed that people don't really understand attention as much as they think they do, right?
Well, we feel as though we have a much
Yeah.
broader scope of attention than we really do, yes.
Mm-hmm. And then what exactly is happening in the brain when we're shifting attention from one thing to another, essentially just changing the subset of information that we're taking in?
Yeah, I mean, so I think here I'll go ahead and argue that we could probably divide up attention into at least a couple of broadly different categories. One category of attention is what I would call perceptual attention, your ability to control which parts of the environment you're focusing on and doing your best to identify and discriminate in the environment. But on the other hand, there's another kind of attention that we could call memory attention or mnemonic attention. So, and this has to do with the information that you choose to hold in mind and sustain in your mind even after you have perceived it. And this is what I'm talking about when I refer to working memory. The information that you're holding in mind voluntarily is being held in this conscious workspace that we refer to as working memory. Now, one thing about working memory is that it's really limited. We can only hold about 2 or 3 simple pieces of information at a time in working memory. So that means that the observer of the world has a really important decision to make. They have to decide which small handful of information they're going to hold in mind. And this is a process we can refer to as attention. That is, you are selecting a subset of the many ideas that you could hold in mind at one time. And by choosing the contents of working memory, then you are kind of using attention to control what you're actually thinking about at any given moment.
So is attention the sole determinant of what enters working memory?
Well, that's maybe putting it too optimistically. That is, we wish that our attention was the sole determinant of what got into working memory, and yet often we can be distracted by things that we were not particularly concerned about at that particular moment. And so when those things intrude into working memory, this makes it a lot harder for us to think about the things that we wanted to be focused on. Now, many people would refer to those types of distractions as things that capture attention, right? That even though I'm trying to pay attention to you right now and talking about you, if I hear a car honking outside, it might divert my attention away from you. Now, my voluntary attention is focused on one thing, but we could argue that my attention could also be automatically captured by other things. And if we think about attention through that from that perspective, then yes, attention does sort of determine everything that gets into your mind. But we then are also acknowledging that we're not always in perfect control of our attention. And sometimes
Mm-hmm.
other things can actually capture our attention against our will.
So then there's a lot of nuance to just saying that attention is the one thing that determines what goes into working memory, right?
Yes. Yeah, there's different ways to talk about that problem.
And then is there any way to remember information without actually paying attention to it?
Well, this depends a little bit on how we define memory. So there are some kinds of memories that you can voluntarily retrieve. You know, if I ask you what your address is or what you had for breakfast this morning, you can usually just voluntarily bring that information to mind. But on the other hand, there is a lot of information that you kind of take in from the environment that you can't voluntarily retrieve because your brain just didn't kind of tag it in a way that allows it to be easily accessed. So, you know, I've been talking about this choice that people make of the things that they let into working memory, the things that they are consciously thinking about. And this is a very important choice that you're making because it really determines what you're able to voluntarily think about and work on. Having said that, there are many other aspects of the environment that will be processed at a low level in your perceptual system of your brain that you do not choose to remember. And yet, those things that you process in that way, even though you might not consciously be able to remember them or be aware of them very well, they might still leave a footprint in your memory. And so there will be some trace of that information in your brain that we could refer to as memory, but it's not as accessible as the information that you're actually taking in on purpose. So people talk about different aspects of long-term memory, and sometimes they will distinguish between information that is consciously recollectable, that you can voluntarily recollect, and other types of memories that are just more like familiar ideas that have been impinged upon your brain, but that you might not be able to consciously retrieve, but they might still have some impact on how you're able to process that kind of information in the future. And so in textbooks or in research articles, sometimes this is referred to as the distinction between recollective memories that you can consciously access and think about the time and place where you encountered them, and then familiarity signals, which are information that you've encountered before, but that which you did not really register in the same way as those recollections.
Right. I think another thing that is especially relevant now is, since we talked about distractions, digital distractions are becoming more and more common, and then they've supposedly shortened our attention spans. But is that true? Has multitasking actually affected attention and working memory, especially in our recent times?
Such a common idea that we hear about in the media and in our culture that attention spans have actually declined in recent decades because of the onset of the internet and social media and kind of the pace of the information stream that we get through digital media. But interestingly, I think there's not very good objective evidence that this is true. If we look at, for example, objective measurements of intelligence and attentional control, which have been happening for many decades, right? For over 100 years, people have been measuring attention and IQ and fluid intelligence. And it turns out that one of the main things they've documented through those types of studies is something referred to as the Flynn effect. And this is actually the gradual increase in intelligence scores that we've observed in humanity across the decades. So the average IQ score that you would have observed in 1900 is actually lower than the average IQ score than you would observe in the year 2000. So there's been this gradual increase that we don't really quite understand why we are seeing this kind of increase. It may be that people are just more used to these kinds of assessments than they used to be a long time ago. But what I'm really saying more broadly is there's not great evidence that people are losing their attentional capacity over the decades as intuitions or as the media kind of have suggested.
So, what do you think has led to this idea kind of coming about? Because this idea stemmed from, especially the younger generation, not being able to focus for long enough. If there's no concrete evidence supporting that, what has led to this believed shortened attention span?
It's a great question. I mean, there are many ideas that are wrong that persist, and I'm not sure exactly how to explain all of those. There's a funny story about this belief about attention control. One of our doctoral students in our lab actually went back and tried to investigate this and try to look for sources for where this idea was first referenced and where it came from, that attention span was getting worse. This is her name is Dr. Kirsten Adams. She's actually a professor now at Rice University, and she's about to move to UC Davis in the fall. And what she found was that one of the first mentions of this idea of the brief nature of human attention span came from, I believe it was a Microsoft technical report, where they were actually attempting to measure attention span. But they used an extremely crude measure, which was that they simply looked at internet click behaviors And what they measured was the number of seconds that elapsed between different clicks on websites. And they found that the number of seconds was only about 7 seconds on average. And so they then argued on the basis of that very flimsy result that human attention span was only 7 seconds long. And so I believe that maybe they also argued that this was similar to what you might expect from a goldfish. And this idea of human attention span degrading to the level of a goldfish is something that you'll also hear in
Yeah.
popular media in recent years. But that particular study has almost no validity as a measure of human attention span. And yet it's just such a compelling idea, I think, that people, when they hear it, they remember it and they tend to mention it to other people. But that unfortunately is not a very good way to figure out what is correct.
Yeah, that makes a lot of sense now that you think about it, because of course with Microsoft's uh, experiment, there's so many variables affecting it, including quality of the actual article, and then now people are relating to it simply because they personally experience it from the constant dopamine pushing algorithms.
Yeah, when you're flipping through Instagram, the things that you pause on for the least amount of time are often least interesting, right? And that's why you flip past them. It's not that you are unable to pay attention to them.
Yeah,
Yeah.
that's true. And then, since we're talking about studying attention and memory, how do scientists genuinely study attention and memory in a way that is controlled and in a setting that you can generalize to a larger population?
Well, as we were discussing in the beginning of our conversation, one really key method for studying attention and memory is to give people tasks that require them to pay attention or to remember things, and then just to see how good they are at doing those kinds of tasks. How effective are they at retrieving or remembering as much information as possible? How effective are they at paying attention to only one subset of the things that you've told them is important and not being distracted by the other things that they might be presented with that are not relevant to that particular task? And this kind of basic type of study is what cognitive psychologists do. Now, as a cognitive neuroscientist, what I'm also interested in doing is looking at the neural signals that accompany people's ability to remember and pay attention to things. So one thing we like to do in our lab is to measure the electrical activity of the brain. We do this using EEG, or electroencephalograms, where we put electrodes on the scalp of our human subjects, and then while they are trying to pay attention and remember different things in the environment, we can actually look at the electrical activity that is emanating from their brain to see how we can track what they're paying attention to and what they're remembering. So one really cool thing that we like to do is to look at the pattern of the electrical signals on the scalp of our subject. And a really cool thing we've discovered is that you can actually measure how many things a person is paying attention to and thinking about just by looking at the pattern of electrical activity coming from their brain. So, for example, I might ask somebody in my lab to look at a computer display that contains different numbers of colors. One color, two colors, three colors. And a cool thing that we found is that we can actually precisely measure how many things they're thinking about at any given moment in time just by carefully analyzing the pattern of electrical activity that is coming from their brain. And another interesting thing we've discovered in recent years is that there seems to be a very common pattern of activity, regardless of what things the person is thinking about. So it might be three colors, or it might be three shapes, or three sounds even. And what we find is that there's a common signature of the number of items that a person is thinking about that we can measure with these EEG signals. And that provides us a very powerful tool because we can now track how many things a person is taking in from the environment in front of them and how successful they are at attending towards specific parts of the environment and taking in only what is important to them. And so that's how we're trying to understand and develop models of this fundamental cognitive ability that people have to select what's important and to hold it in mind and we can actually measure that with these EEG signals.
Yeah, I think that's really fascinating that you can use electrical signals to figure out the number of things that people are paying attention to and exactly what is happening in the brain at a certain point of time. Are there other tools that are also used to study attention and memory?
There are many tools that are used. Another one that is very popular in the cognitive neuroscience literature is functional magnetic resonance imaging. This is where people are actually lying in an MRI machine. And in an MRI machine, basically you're surrounded by this powerful magnetic field. And then they're able to kind of perturb that magnetic field in a way that actually allows them to detect what's going on inside the human body. And so this has been one of the most important medical technological advances of the last century, right? Is our ability to precisely measure the structure of small parts of the human body using MRI. But a really important discovery was made in the 90s where they figured out that they could also measure not just physical structures, but also the amount of oxygen that was present in specific regions of the human body. And so they realized that by directing this analysis towards the human brain, that they could actually detect the level of oxygen in the blood that was circulating through the human brain. Now, why is that important? Well, it turns out that when the brain is active, when neurons are active in the brain, they are using up a lot of energy. They're using up a lot of oxygen and glucose. And those brain cells then need to be replenished. They need to get extra glucose and oxygen to come back to them so that they can continue to work. And so if we measure where in the brain oxygen levels have gone down, that is a pretty good indicator of where there was a lot of neural activity in the brain. So using functional MRI, we can now get a pretty good estimate of exactly where in the brain neural activity is higher and lower. And that has provided us with a lot of important insights into how different parts of the human brain work, because we can look at the patterns of activity across the human brain and try to see how they relate to the different types of cognitive tasks that they might be performing.
From this technology, were you able to find any surprising areas of the brain that are connected when working with attention and memory?
I think that the broad answer to this question is that virtually all areas of the brain are connected to each other in important ways. Like I think in early textbooks that talk about how the brain is organized, there's a tendency to say, yes, motor activity is in this specific location and visual activity is in this specific location. And they try to parcel the brain as to having separate modules for all these different types of tasks that are going on. And there is something real about those parcellations, right? There are different functions of the brain that do seem to be somewhat localized to particular parts of the brain. But I think a more modern view is that almost any function that is of interest, such as memory or attention or decision making, it's really going to be based on a complex, connected web of activity that almost encompasses the entire brain. That the brain is kind of working as a really tightly connected network. And all of those different regions are working together to perform what seem like relatively simple tasks. You look out into a crowd and you recognize your friend. Well, this is a combination of visual perception and eye movement control and long-term memory retrieval and decision making. And so all of these different components of your mind have to work together, which means almost every aspect of your
Yeah,
brain is also coming into play.
right. Yeah, I think that's very interesting to think about because people would not intuitively understand that in a single simple task, almost everything needs to work together because you're using so much more than you ever realize.
Yes, it's true.
And then I know that your recent work has also involved neural decoding techniques. What exactly does that mean to decode the contents of memory and attention?
Yes. Well, so I was just describing a moment ago how we can actually tell how many things a person is thinking about by looking at
Mm-hmm.
the pattern of activity on their scalp, for example, electrical activity. And that is one example of decoding, right? Where we are actually able to draw a conclusion about what or something about the nature of that person's thoughts by looking at the pattern of electrical activity from their brain. Now, likewise, with functional magnetic resonance imaging, we can look at precise patterns of activity in specific regions of the brain. And what we had done in 2009, we found that we could look at the pattern of activity in the visual cortex of the human brain, where people's visual activity is being first processed. And then we could actually tell from that pattern of activity what color the person was currently holding in mind, or what angle, what orientation they were currently thinking about at that time. And this has been done with many different types of experiments over the decades, where they've measured things like what category of object is the person thinking about? Are they thinking about social information or not? What types of decisions are they making at different times? These are all types of information that can be inferred by looking at functional MRI activity. So all of those would count as examples of decoding of mental states that are happening with people that are being measured.
How accurate has this technology or these techniques become?
I think it really depends upon the particular question that's trying to be answered. If you just wanted to know, for example, what side of space is a person paying attention to, you can be pretty accurate at making those kinds of judgments. And so, for example, they've used some of this type of technology with EEG activity to try to help people to control the direction of a wheelchair, for example. Imagine a person who's not able to move their arms. They might be able to use EEG activity to actually try to guide the direction of the wheelchair that they're in. And that provides them with some extra ability to kind of function in life, despite the fact that they have lost control of some of their limbs. Now, it also depends upon the particular technique that's being used to measure brain activity. So in some laboratories, they've actually implanted chips into the human brain that have allowed people to control robotic arms. And those arms are able to reach out, grab a cup, and allow that person to take a sip from that cup. So it's exquisite motor control that they're achieving. But this requires this kind of invasive approach where they're actually putting electrodes inside the cortex of that human's brain. And that's what's giving them this exquisite ability to decode things like motor control signals. Now, in our kinds of experiments that we're running, we're not actually putting detectors inside the brain. We're just actually measuring activity using MRI or using EEG detectors that are outside the skull. So we have far less precise ability to measure neural signals with those types of approaches. And that, of course, means that we're much more limited in how precisely and how quickly we can measure those types of decoding signals.
Right. This technology almost sounds like science fiction with how incredible it is, because you can essentially infer what people are seeing or thinking, and you can use the brain to control things physically just from signals. But then, of course, this also could be limited by many barriers. So there are a lot of ethical or philosophical limits to this?
Yeah, it's an interesting question, and I know that some people worry that the idea that an outside observer could sort of observe the content of your thoughts, for example, may be threatening in some circumstances. I think there's not too much to be threatened by in current times, because when I describe these experiments where we're able to measure, how many things a person is thinking about, or maybe decode what color they're thinking about, these are all in volunteer subjects who are actively kind of cooperating with this experiment, who are staying really still so that they do not disrupt our ability to measure these neural signals. Usually it requires hours of their time for us to measure enough activity for us to start to show that we can detect these patterns. So it's not like anybody could currently use this kind of technology to capture somebody's thoughts against their will, for example. And I think this is part of the ethics of doing these types of psychology and neuroscience experiments. Every person that comes into our lab is given a careful description of what they're participating in, and we're getting them to decide at that time whether they agree to participate in this experiment. And
Right.
we have to be very careful to explain to them any kinds of downsides to this experiment or any kinds of benefits that they might get. So that's a really critical part of any kind of human subjects experiment that we would do in psychology or neuroscience. And that's why I feel pretty good about the ethics of those kinds of experiments. Now, if somebody in the future developed technology that could involuntarily read our thoughts, then I suppose we might have a more important conversation about the ethics of that, right? If
Yeah.
they started to use it on individuals that didn't agree, then I think we might all start to become concerned.
Yeah. So then, essentially, at least at this point, it's not really a worry, especially because of how limited the technology is and how many different methods are used to at least inform anybody who's going into these experiments, right?
Yeah, that's the way I would put it.
Okay. And then I wanted to also pivot into specifically attention disorders. Of course, this is incredibly relevant to academics or learning in general. So, how does learning about attention disorders like ADHD, for example, tell us, like, what does that tell us about memory and attention research in general?
Yeah, I think this is a really important question, right? Because one of the important motivations for our carrying out this research on memory and attention is to try to help people, right? To try to come up with ways to rehabilitate attentional disorders and to assess when there are attentional disorders as well. Now, having said that, I have actually done some ADHD research in the past, although it's been quite a while since I engaged in that kind of research. And when you read the scientific literature on attention deficit disorders, for example, it's interesting and kind of surprising that it's somewhat difficult to find really excellent evidence that scientific objective measurements of attention are actually disrupted in people with ADHD. Many of the types of tasks that we would use in the laboratory to measure attention and memory function are largely performed normally by people who have attention deficit disorders. And I think this is a really interesting mystery. It means that there's probably something fundamental about what is challenging for ADHD that we have not fully captured with some of our approaches for measuring memory and attention in the laboratory. One thing I've always noted, and I have a child who had ADHD as well. And one thing I'd always noticed was that they were actually pretty good at paying attention to certain things for very extended periods of time. If it was a video game that they were particularly interested in, they might be locked in on that thing for 5 hours and not show any signs of difficulty in paying attention to that particular activity. And I think this is a common story that you'll hear from individuals with ADHD, that there are certain activities that they just don't have trouble with paying attention to.
Right.
And this has given me a suspicion that there may be something beyond attention that is really challenging in the domain of ADHD. And it might have something to do, for example, with the certain types of signals or activities that are motivating to individuals. And some things are a lot easier to be motivated by than other things. And that might also be one of the fundamental challenges here, is our ability to kind of decide to pay attention to something that we might not really be intrinsically interested in. And maybe this is why we hear a lot of complaints about ADHD in school, is that there are many topics that we study in school that we might not have voluntarily chosen to study, perhaps.
Yeah.
And this could be one of the big challenges that we need to address with ADHD, is helping people to pay attention to things that might not be their favorite thing at that time, but that they would like to be able to pay attention to because they see the long-term benefit of doing that kind of activity. But I'm really a little bit out of my depth here, right? I am not an expert in ADHD at this time, but this is some of some of the kind of observations I've made, and where I think that there could be some interesting questions that we could raise about how to think about this particular clinical disorder.
Right, yeah. And then, so you're saying that, of course, a lot more research has to be done, especially in helping people with ADHD fit into the school and classroom environment by making it more suited for them to actually feel that they're interested in it or they would gain something for it, because ADHD is a lot more complicated than simply that somebody can't pay attention to something, right?
That's what I suspect, yes.
Okay. What do you think the scientists are still trying to understand about such conditions, or generally a lot of the questions in attention research?
Yeah. So what are the key questions that people are trying to focus on right now to understand, disorders of attention and memory? I mean, I think one of the really important domains of research is to understand neurotransmitter systems in the brain, things like dopamine and acetylcholine, and how do different neurotransmitters allow kind of help to support the circuitry that allows us to voluntarily pay attention to things. So we've been talking about how important it is that we get to choose what we think about, right? And our ability to voluntarily pay attention to things is in part determined by our own goals, about what's important to us in the environment right now, but also by our past experiences of what is rewarding to us to pay attention to, right? And I think that if we can understand the neurochemistry of reward and voluntary control, that is a really important avenue for us to understand better drug therapies that might help people to be better at paying attention as well. So I know that that's a really vibrant area of research, and certainly this is part of what allowed us to develop things like Ritalin or Adderall or other types of approaches that really do seem to provide a lot of help for individuals with ADHD.
Right. And then what do you think are just the most exciting developments happening right now in attention and memory research, especially the ones which hold the most impact?
Yeah, I think, one thing that's been really transformative for cognitive neuroscience is the development of really sophisticated computational and analytic approaches for understanding the patterns of brain activity that we are observing. When I talk to you about decoding the color that a person is thinking about or decoding how many things that they are thinking about, these are based on the types of data that we had available to us in 1995. But the ability to analyze those data in such a clever way did not come about until more than a decade after that, right? That is, our ability to understand the human brain is affected by two things. First of all, what signals can you measure from the brain? But second of all, just as important, if not more important, is how do we actually understand those signals? How do we analyze those signals to extract as much information as possible from those patterns of activity? And that has really been a revolutionary change that has occurred over the last 20 years, where we've developed all of these new analytic techniques that allow us to learn so much more from EEG and MRI activity than we ever could before, even if those signals themselves are pretty similar to the way they were 20 years ago, right? So I think that's one of the most important and exciting developments in cognitive neuroscience is changes in our analytic ability and our ability to understand complex signals. And I think that, interestingly, the advent of artificial intelligence may actually help to accelerate some of those developments, right? Where it's allowing people to implement different types of analysis pipelines that they might not have been able to easily implement before, and to do it much more quickly than they could before as well.
Right. Yeah, I think that's definitely something to think about, because the field has made a lot of progress in just a few decades, and we have no idea how it'll look in the future.
Yes, it'll almost certainly be surprising, whatever it is.
Okay, so before we wrap up, I just have two quick questions. If students listening are interested in joining this field particularly, what advice would you give them?
Well, if they're interested in cognitive neuroscience, then I think that the first thing to do is start to read and start to kind of look out at the world at what people have found. That's another really cool thing that's happened in the last 20 years, right? Is that the amount of information that is available for free and easily obtained on the internet, on YouTube, on different types of media channels, it's really staggering how much great information you can find about this stuff. So I'd say just kind of diving in and finding good sources of information and starting to read and watch and listen and understand what people are thinking about and what they've understood. This is a great way to kind of determine if this is something where you would be motivated to do formal study of this kind of stuff. College is a great choice for people that want to really dig into formal study of psychology and neuroscience. And that's where I got my initial start in this field. And I think that finding those kinds of opportunities is a really great way to try to break into this type of discipline and this type of employment. And I think another thing I would really always emphasize is if you are a college student or even a high school student who wants to learn about this kind of thing, then trying to get some experience actually participating in research on psychology or neuroscience is just such a powerful way to get a perspective on the field that you can't really get just from reading textbooks. When you read textbooks, what you're hearing is the conclusion of a story. Like, what do they believe after all these years of work? We can find that out by reading a textbook. But what you don't find out is, what does it take to learn that stuff? What are the everyday steps that you need to make to actually carry out a scientific experiment, to design a scientific experiment, or to even conceive of the question that you want to ask? And those are really exciting parts, I think, of being a scientist. And the only way to really learn about that is, I think, to get in there and actually do it and kind of participate in that process.
Right. I think that's great advice, especially research can be very eye-opening, and reading more can truly help you understand about the field before going into it too deep. And then last question, if listeners could remember one thing from this episode about attention, memory, or the brain in general, what would you want them to remember?
Well, I suppose I'd boil it down to this idea that what you can actually think about at any given moment, the capacity of your working memory, highly limited. So your ability to control what gets in and what you actually hold in that precious state, that's kind of the key to so much of our ability to be intelligent beings. And so this is why I find it to be a fascinating topic. How do we control what's in our mind? This has a lot to do with what we can accomplish as intelligent beings.
Yeah, for sure. Dr. O, thank you so much for joining me today and for helping make such a big, incredibly complex topic seem so approachable and engaging. Of course, attention and memory shape nearly every moment of our lives. And what we notice is incredibly important. Understanding the systems behind that will help us understand ourselves better. For listeners, if this episode changed the way you think about focus, memory, or the mind, share it with somebody who you think would enjoy the conversation. If you guys enjoyed this episode and learned something new, make sure to follow on your favorite podcasting platform or on YouTube. I'm Avanish, this is The Early Perspective, and I'll see you in the next episode.